Last episode, an agent answered a real support ticket and it sounded exactly like company policy. Here is what it actually said. Checking the delivery log for a specific alias requires access to account level data that I'm not able to pull up directly as a support agent. I read that line back because at first it sounds responsible, but it wasn't policy at all, and that's the part that got me. The agent was simply blind, and it dressed up its own blindness as a rule. So here is the question for this episode. Can 4 new tools make that same agent honest without changing the model underneath it at all? Stick around, because by the end of this episode, 56 becomes 68. Welcome back to the series. Last episode, our very first version of this agent scored 56% on our test set because it could answer questions but couldn't check anything. 6.7 million people download the Claude Agent SDK every week, and almost none of that survives contact with real customers. That's the chasm this series is about, and today we lay the first plank across it. The plan in one sentence: give the agent eyes. 4 read-only tools so it can look at the account before it answers, and the scorecard tells us what that was worth. Everything today lives on this episode's branch, so clone it and run it yourself. The SDK moves fast, so trust the repo over my screen. Let's start with the first principle, and it surprised me the first time I understood it. The model never reads your code, not one line of it. When it's deciding whether to call a tool, it only ever sees 3 things: the tool's name, its description, and its input schema. So here is the idea to walk away with. A tool description isn't documentation for a future engineer. It's a prompt written for the exact moment the model has to decide what to do next. Think of it the way you'd brief a new hire. What this thing returns, when to reach for it, what it will never hand them. A vague description doesn't make the tool weaker, it makes the model guess. And we are not leaving that as a claim because the scorecard later in this episode proves it. Second principle, and it's about trust. Every tool you hand an agent is real power given to something that only guesses. So the boundary around that power is your actual security model built into code. Here's a phrase worth remembering: least privilege, the smallest set of powers that still lets the agent do its job. That's not politeness, it's architecture. Read only by promise is a prompt that says please don't write anything. Read only by construction means the ability to write doesn't exist on the tool surface at all, and that's the one we are building. The same boundary holds for other people's data, and asking about an account that isn't the customer's gets 2 words back, not yours. No owner name, no counts, not even a hint that the account exists. Here's the payoff. If the model gets confused or tricked, the worst it can do is read the customer's own data. Nothing more. And that's the whole design we're about to build. Time to build, we're adding 4 tools, and every one of them is read-only. One looks up the account, one checks a detail on it, one lists everything on it, and the last reads the recent activity log. Here is the first one, and I want you to do something unusual. Don't read the code. Read the description instead, because that's the only part the model ever sees. It tells the model what comes back, that it's read only, and one standing order: call this first for any account ticket. Even a miss is useful here. No account exists is an answer the model can act on, not a crash. Second tool, and this is the one with the guard that actually matters. It checks a single detail on an account, but only for the customer who wrote in. Ask about somebody else's, and you already know what comes back, not yours and nothing more. 2 layers make that happen. The data layer never hands the record over, and the reply tells the model how to behave. And here is read only by construction, the pattern I mentioned earlier now actually built. The database key underneath this could write, so the safety lives right here in one file. This file exports 4 read queries and nothing else. So auditing this agent's entire write access means reading one file. One honest note, the evals run on fixed sample data through these same 4 functions, so the agent can't tell it's not live. That's the surface, same model and loop as before. The only thing that changed, what it can see and touch, plus a system prompt carrying the support policy. Quick detour because MCP is carrying a lot of hype right now. Wiring these 4 tools into the agent takes exactly one function call, and it turns them into what's called an in-process server. That just means plain TypeScript functions running inside the agent's own process. No subprocedures, no network hop, nothing else to deploy. V1 mounts that server next to the docs server from episode 1 behind an explicit allow list. Keep half an eye on one line in that config, the one called always load. It looks like boilerplate, but it's the scar tissue from a bug in episode 4. An external MCP server, someone else's tool, plugs into that exact same slot using the same protocol. So here is our rule for this whole series: consume, don't build. If a vendor already ships a server for something, mount it and move on. For your own product logic, in-process tools are simpler to write and easier to test. Now, the mistake beat, and this one's worth remembering. The classic tool design failure isn't a missing tool at all, and it's a description that says nothing. Here is the experiment. I keep all 4 tools exactly as they are, but change every description down to 2 words: gets data. The type checker is happy, and the demo still runs because nothing changed. But the model is now guessing at the exact moment it needed to be sure. So watch 2 real tickets when the descriptions do their job again. First ticket, a customer says an address they set up stopped receiving mail entirely. With real descriptions, the agent checks the account step by step and finds that the address never existed because the customer had mistyped one letter. With gets data everywhere, the earlier version sent that same customer through generic troubleshooting instead. Second ticket, a customer mid-interview worried they're missing a recruiter's emails. The agent reads the activity log, sees 2 deliveries failed on our side, and owns it. Same model every single time on both tickets. The only difference is a surface that tells the model where to look. That one line, always call this first, lives in one description, and it beats every trick of prompt tuning we've tried. Now the scorecard, and this is where all of that talk turns into numbers. Same 25 tasks as last episode, graded the same way. Watch each metric land one at a time, starting with the one that matters most. Task success rate 56% last episode, 68% today. Unrecoverable errors still 0, exactly like last episode. Median cost per ticket, basically flat, still right around 2 cents. Human interventions per 10 tickets, that number dropped 2. So here is what those 4 numbers are telling us. 12 points of success at a lower cost, not a higher one. Grounded answers finished in fewer back and forth turns, so better came out cheaper. And an agent that can check the account stops escalating things. It could just answer itself. Add it up across the full run, and the total cost went down, not up. That's layer 1 of the bridge, and now it's measured, not guessed at. Let's recap back to the question I opened with. Can 4 tools make a blind agent honest without touching the model at all? Yes, 56 became 68, at a lower cost, not a higher one. 3 things made that happen. The model only sees a tool's name, its description and its schema. So a description is context engineering. Scope is a security boundary that lives in code, which is why not yours means not yours. And for MCP, consume other people's servers, write your own tools in process. Now, an honest question, how do I actually know any of this moved the needle? Because I hand graded 25 replies myself again, one at a time. That doesn't scale and it misses a whole class of bugs. Next episode, an eval harness, the kind that catches a real bug on camera. Clone this episode's branch and run V1 yourself before you get there. See you next time.